We've been working our way through a series of videos on LED strips, something he likes to call lead tape. We've had some questions about static, and why do we need to worry about static, Gordon?
Okay, so static electricity, you'll be very aware of it. You know, you walk you go skidding down a supermarket on a trolley and then touch the shelf, and you do get quite a belt from it. When you're working with electronics, that spark that's generated from your body can actually destroy the components, including the LEDs within the lead tape.
So we're straining into the world of electronics now, so therefore static becomes a big issue to us as electricians.
Yeah, I mean, anyone who's ever been in a factory where they assemble electronics or work with electronics will be highly familiar. Those factories go to enormous precautions to protect themselves and the product from that potential for damage. And you know, it's really about mitigating the risk. You can never get rid of it fully, but what can the electrician do to minimise that risk when working with lead tape?
So we're going to minimise the risk. I see you've got a couple of bits there on the table. It looks like, you know, a new Apple Watch on your wrist there. What's that all about?
Okay, so this is the most important bit for personal protection, so that you don't build up a static charge on your body. So this is a conductive wristband.
Okay.
And get ready for this. What I'm going to ask the electrician to do is connect yourself to earth.
Oh, right, okay. So let's work that one through in my own mind. So if I connect myself to earth potential and there's an earth fault, I might have the best possible conductive path to earth, and the fault current will go through me to the greater mass of earth. Is that what we're going to do?
Well, I'm not quite on about putting an earth strap around you and 10 millimetres worth of cable down to a suitably grounded point. What you'll find, there's a whole range of products designed to help protect static. So I've got the wristband. Okay. I can connect that to a special plug. Okay. So you notice this plug only has an earth connection.
I'm glad you pointed that out.
And it's also got in there, it's got a number of, 1 mega ohm resistor. So 1 million ohm resistors. So the kind of value you like when you get a successful insulation test, you want to be above 1 mega ohm. So it's conductive, but only very slightly.
Okay, so that makes sense. That goes in a normal 13 amp plug top, and we can clip into there, and we've got at least a 1 mega ohm path to earth then through us, and that will reduce the static.
Yep.
And we've got a wristband on there, and you're going to show us
wristband. So I mean, again, wristband. So this stuff, all the standard in ESD protection or electrostatic discharge protection is these 10 millimeter press studs. Okay. They're everywhere, so it's either end of there. I've got one on here, so I'm going to click that to there. In our videos, I'm earthing myself through our lab power supply. Okay,
so the power point, earth point there, now you're now connected to earth.
Yeah, so I shouldn't build up a static charge.
Okay, and where is the 1 mega ohm resistor in that lead for me?
It's actually in the lead. It's probably moulded into the plug there. So if I was to, I'll measure one here. Okay. I can quickly, just to prove it, just in case anyone's worrying, and don't make your own at home. You can see straight away there, but it's actually a 2 meg one. Okay,
so that's a 2 mega ohm resistor. So that's the first precaution that we're going to take. Yeah. We're going to be in a controlled area, and we're going to obviously be connecting ourselves to earth. What about the equipment when it arrives maybe on the bench and we're working with it? What have the manufacturers done in order to reduce static or the influence of static in the environment we're working in?
So you've probably, so if you're ever working with lead strip, lead tape, you'll notice a lot of the time it comes in a foil bag.
It does, yeah.
So this is special conductive packaging.
Conductive packaging.
Yeah. So again, not something you wouldn't be able to. If you measure across that, you'd struggle to get a resistance measurement. But it doesn't build up static charge. It's very slightly conductive, so it doesn't build up a static charge.
Oh, right. Okay, that makes sense.
So you'll find that the reels themselves. So lead tape comes in a plastic reel. Yeah. This is a special anti-static reel. And then even things like bubble wrap. So you'll see we've got some.
Yeah, it's pink in colour. That seemed a bit odd, and so is the packaging here.
Yeah. So the last thing you want is, again, so this is conductive bubble wrap or anti-static bubble wrap.
Makes sense. Yeah.
So the last thing you want to do, you've got your electronic components out, you're working on them, is to come in with something, wafting it around and building up a static charge, and then take that across your bench and zap some of those components.
So we can see how important it is there to the electrician when working, in this case, with electronic components in order to reduce the static buildup on themselves and the packaging in which they use them.